This problem will help reinforce the fundamental counting principle, which you'll be practicing on tonight's assignment. The Naples Country Club has the following rules for coding their membership cards. Rule 1. Letters and numbers may be used only once in each card. Rule 2. A membership code must be 2 numbers followed by 2 letters. So we need a number, then a number, then a letter, then a letter. And they can't be repeated, okay? Using the given rules, list the possible codes for membership cards that can be made from these letters and numbers. I mistakenly thought they were going to ask us how many codes could be made. Let's do that problem and then let's answer the question that's being asked. How many choices do I have for this first number on the membership card if I'm only pulling my number from these characters? There are 4 numbers here. I could start the membership card with a 1, a 6, a 7, or a 5. So there are 4 choices. The second number, there are no longer 4 choices because whichever number I've chosen for the first number is no longer available for the second number because of this rule. And so let's say I started my membership code with a 1. I have to choose from the 6, the 7, or the 5. So there are 3 choices for the second number. The first letter could either be a P or an N, so I have 2 choices. And then once I make that choice, there's only 1 letter left. So the total number of possible membership card or codes from these rules and using these limited number of characters would be 4 times 3 times 2 times 1, which is 24. By the way, 4 times 3 times 2 times 1 is 4 factorial. But we're getting 4 factorial coincidentally here and not for the reason you'll start to see factorials pop up so much when we start to focus on combinatorics. What this question was asking us to do when it said to list the possible codes would be more like a tree diagram. The first really should show this better. Let me assume that you've written that down, or of course it's a video, you can always back it up, pause it if you haven't, but the tree diagram would help us list all the possible codes. Like for example, the first number could be a 1, a 6, a 7, or a 5. The second number, if the first number was a 1, can only be a 6, a 7, or a 5. But if the first number was a 6, the second number could be a 1, a 7, or a 5. If the first number was a 7, I could have a 1, a 6, or a 5 for the second number. And if the first number was a 5, I could have a 1, a 6, or a 7 for the second number. First letter, letter 1, can be a P or an N. Whatever combination of the first 2 numbers I chose, I could have a P or an N for the first letter. I'm not going to do the whole thing, but once I've chosen the first letter, the second letter would be determined. There's only 1 letter left. So if my first letter was a P, my second letter would be an N. If my first letter was an N, my second letter would be a P. And because we're going to get 6 here, and we'll have 6 here, and you'll see that we'll have 4 groups of 6. I think that's another way to see that there are 24 possible codes. But the list of all the possible codes would be, I mean, this is pretty tedious to really do it the way it's asking. 16PN, 16NP, just following those branches and listing them. You should be able to do the next one on your own, but the next one should be done with a calculator, just like tonight's homework can be done with a calculator.